Hello, my name is Brent Walker, and today I will be going over conduction, convection, and radiation heat transfer. In the world we live in, heat transfer is known to always move from the hotter object to the colder one. The transference of heat from one place to another can be shown through three different methods: conduction, convection, and radiation. All three of these methods are very similar, but come with a few differences. Conduction and convection differ from radiation, mainly because they have to have matter to transfer heat through, while radiation does not. To better explain how heat transfer works, these methods must be understood in better depth. Before we get started, here is a very simple runout of all three methods using a campfire. As an example of convection, as the heat rises, is the smoke that you feel. Conduction is transferring heat through an object, like a metal object like this poker that the hand is using, and radiation is the heat that is coming off the fire that you can feel with your bare hands. Conduction is defined as the transfer of heat between objects or substances that are in direct contact with each other. Heat has the ability to make atoms vibrate and also set electrons in motion. The heat is transferred when the vibration or motion communicates to neighboring atoms. The vibrations that happen in these atoms have to be close together in order for conduction to be an efficient source of heat transfer. This is why solid matter works much better for conduction, as liquids and gases spread the atoms apart in their forms of matter. To exemplify that of conduction, metals are an excellent source of conduction. Copper, steel, silver, and iron have closely packed atoms within them. If one leaves a metal spoon in hot soup, the spoon will soon be very hot as well. On the opposite end of this spectrum, if one was to touch a cool metal object, they feel even colder to us because they are conducting heat away from our hands. Some substances are also very bad at transferring heat through conduction, which are known as insulators. Wood is pretty good at insulating, which in turn makes it a very poor conductor. For instance, when a metal pot is on the stove, it quite possibly will have a wooden handle so it does not burn to pick up the pot after cooking something. Air is also known for being poor at transferring heat through conduction, which is why when someone reaches their hand in the oven to grab their plate, it doesn't burn. And here is a picture of conduction in action with a pot. As the heat touches the metal, it warms up the insides of it. And for more conduction, here is an example of conduction through a ceramic mug. As you can see in the picture, it zooms in on the coffee mug and shows that coffee particles with a higher average kinetic energy collide with the container wall and transmit their energy to the surroundings, which is shown on the outside of the wall with the blue atoms that are bouncing everywhere off the coffee mug. Next, convection is defined as the transfer of heat by movement through a medium, like air or a liquid. It is the primary method of heat transfer through gases and liquids. This is how to imagine convection works. Imagine a room full of children who have just had a bunch of cookies. They become quite energetic and start running around the room. If someone were to open the door and let them outside, they burst out and start running around the larger space, spreading out in the yard. To get technical, this is what happens to fluids when heated. Instead of being confined to the said yard, the fluid's warm, thinner molecules begin to move upward, while the cooler, denser molecules begin to sink. I never actually realized why houses in the north have their air vents on the floor compared to houses in the south having theirs on the ceiling until I researched about convection. Basically, heat rises so when the air vents are on the floor, the heat takes the place of the cold in the air and drops it to the floor when it's denser. Because it's colder up in the north, this is why that's happening. Since houses in the south tend to be hot on the inside, it only makes sense that the vents are on the ceiling to push the cool, dense air conditioning down on the heat to quickly cool the inside of the building. Convection is also known in its ability of circulation in a liquid. When heating a pot of water over a flame, the heated water expands and becomes more buoyant. Cooler, more dense water near the surface descends and patterns of circulation will then be formed. I think a really cool example of this process is shown when heating cooking oil in a pot. Heating the oil produces changes in the index of refraction of the oil, making the cell boundaries visible. When the circulation patterns form, it is noticed that there are wall-like structures visible that represent the boundaries between the circulation patterns. To elaborate even further, convection also is thought to play a major part in transporting energy to the surface of the sun from its hot center through convection cells, which transport this heat energy. Likewise, the hot magma that we have beneath the Earth's surface is also a form of convection due to the transference of heat it has. And here's for further understanding of convection. You can see here as the pot is heated up, the liquid inside, the water cools, becoming more dense. The water that's cool, like at the top, from away from the burner, becomes more dense and it sinks to the bottom, while the hot, less dense water rises, which is a similar demonstration to the vents in north houses compared to the south houses. It circulates a liquid in this case. Lastly, radiation can be complex compared to conduction and convection, in that it can transfer heat energy along electromagnetic waves, like light waves and radio waves. When a wave comes into contact with an object, the energy is transferred to the object in the form of heat. Sunlight is the biggest form of radiation due to it being able to directly radiate heat through space to our planet without the aid of fluids or solids. Just think, it has the ability to heat up an object caught in its rays through absolute nothingness, which is necessary to provide life for our planet. Radiation can also potentially be a dangerous form of heat transfer for us and the environment. When thinking of the heat transfer rate by radiation, we also tend to think of various forms of cancer that these rays can create. Radiation consists of several types of subatomic particles, principally those called gamma rays, neutrons, electrons, and alpha particles that shoot through space at very high speeds, around 100,000 miles per second. Unfortunately, these particles can easily penetrate deep inside the human body, which is dangerous to our biological cells that make up our existence. They attack these cells and pretty much destroy them. Since we all potentially have cancer in our bodies from the beginning, radiation kick starts that reaction, which will either kill the individual cell or recover it to the point that it will cause cancer later on. I know this all sounds pretty terrible, but in reality, cancer has been in our lives and will be in the future lives of our race. It is calculated that every person in the world is struck by an average of 15,000 particles of radiation every second of his or her life. These particles total out to be 500 billion per year, or 40 trillion in a lifetime, all being from natural sources like sunlight. How is it that we are able to not succumb to cancer from all of this radiation we are absorbing? Well, every single particle of radiation has the potential to cause danger to our bodies, as we are frequently told that no level of radiation is fully safe. Luckily, what saves us from this demise is the probability for one of these particles to cause cancer, which is 1 chance in 30 quadrillion. Besides the potential danger of radiation, heat transfer, it is also part, besides the dangers of radiation heat transfer, it is also part of a useful source of energy, nuclear power. Much of the public agrees that nuclear power is the energy of the future. It can create and contain so much power to provide for the planet. This also causes groups of people to get together to try and destroy particular parts of the world, as these nuclear power plants have the potential to go wrong and cause immense danger for miles around inhabited land. The high amounts of radiation in these reactors are the source for this potential danger, which makes it controversial. So now that we understand how big radiation has an effect on the world, it is easier to end with other common, safer examples of radiation heat transfer that include campfires, microwave ovens, light bulbs, and even the human body. Microwaves are well known to everyone as producers of electromagnetic wave that heat up our food. Campfires emit light waves that transfer heat to objects through radiation, but it is also known to transfer heat to the surrounding air, which is a form of convection heat transfer. Light bulbs are similar to campfires at light emission through radiation heat transfer, but light bulbs also transfer heat by conduction because of the bulb itself heating up. It is also interesting that the human body is considered to have radiation heat transfer. We emit electromagnetic waves, which I never considered to be defined as radiation heat transfer. So, in conclusion, conduction, convection, and radiation are very much related in terms of heat transfer. As shown earlier, some of these methods are even combined in objects like a light bulb or campfire, shown in earlier slides. We as a human race come into contact with them at some point during our lifetime. They are considered to be useful means of our survival, and can also be potentially dangerous in our survival. All in all, this knowledge of the methods of heat transfer helped me deepen my understanding of how important they are in the physics of our world and beyond. And here is the works cited page of all the pictures I have used in my presentation. Thank you very much.